Alright, in this video, we are talking about geometric series, and we know that geometric series is just the sum of n terms in a geometric sequence. A geometric sequence or geometric progression. So here we have two examples of a geometric sequence. We have 2, 4, 8, 16, and obviously R here is 2, and the number 2 example is 2, 1, 1 half, 1 fourth, and R is 1 half. Okay, so what we are going to do is to get the sum of all of some n terms for this uh, sequence, and let's take a look at number 1. As you notice, in number 1, if you're going to continue that, okay, the question is is there a way to get the sum up to, let's say, infinity? Okay, for number 1, is there a way to get all the sum of the terms until infinity? Okay, so that is the question. So if you're going to take a look at number 1 and observe the progression of the sequence, you'll be having 2, 4, 8, 16, 32, 64, 128, 256, 512, and so on. So as you can see, when the sequence progresses, the number becomes bigger, and because it's up to infinity and we're concerned getting the sum to positive infinity, I think that is not possible for a problem like number 1. Okay, because the numbers just the terms just become bigger and bigger, and imagine if that's going to positive infinity. So in number 1, we can only get the sum of first n terms for number 1. So that's for number 1. When the progression becomes bigger and bigger, we can only get the sum of the first n terms. Okay, so how do we do that? So we know that the geometric series is that S sub n for some terms, a sub 1 uh, 1 minus r raised to n divided by 1 minus r. Okay, so if you're concerned with remember, we are still talking about number 1. If you're concerned with sum of the first 10 terms, okay, so we will have S sub 10, or sum of the first 10 terms, a sub 1 is 2, which is our first term, and you have 1 minus r raised to 10. R is 2, so that's 2 raised to 10, divided by 1 minus 2. You'll probably have 1 minus 2 is 1 minus 2 is negative 1. That becomes 2 times 1 minus 2 raised to 10 is, that's a pretty big number, so 2 raised to 10, that becomes 1000, then over negative 1, that becomes 2046. So if you're going to add all of this 2, 4, 8, 16 until it's 8 terms, okay, a 10th term, so we'll get 2046. So getting the sum of its finite terms, okay, finite terms, okay, so because you cannot get the sum of the infinite terms for number 1. So for number 2, the question is again, is there a way to get the sum of all the terms of the sequence number 2 up to basically up to infinity? Okay, so look at this. Let's take a look at the behavior of the number 2 sequence. 2, and we know that r is for that sequence is 1/2, so that becomes 1/4. Anyway, how do we derive the formula? We're gonna talk about that in our next video. There's another video for how do we get with s sub n equals a sub 1. So I'm gonna provide another video for that for understanding purposes. So we have 2, 1, 1/2, 1/4, and we have 1/8, and so on. As you can see, the question is, can we get the sum of this sequence until to its infinite terms? Okay, is there a way? Okay, is there a way? So let's take a look at the behavior of the graph. So 1/2 becomes 1/4. Basically, 1/4 is lesser than 1/2. So 1/8 is less than 1/4. So it becomes, oh, the terms become smaller and smaller and smaller and smaller. Okay, but that's not the highlight of the sequence. The highlight of the sequence is that is there a way? Is it possible for the sequence to get to 0? Because from 2, 1, 1/2, 1/4, 1/8, it getting smaller, smaller, smaller as 1/16, 1/32. That's becoming smaller, number 1. So this one, it will not actually reach 0, obviously, because if you're going to multiply, you will only reach 0 if you're going to multiply a certain number by the term by 0. Okay? But since you're multiplying each term by 1/2, you will not really get into 0. It will get closer, 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 closer to that. Okay, that's what that's what we call asymptotic in nature. Closer, closer to 0, but it will never really get to 0. Okay, obviously it will not go beyond 0, the negative numbers. Okay, so that is the case here. Okay, if it doesn't if it will not, there's something like a limit to that, okay, to the terms, but it's actually 0, but it will not really get to 0, unlike in item number sequence number 1. As long as you multiply each term by 2, the number will just keep on making it bigger, 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 until what infinity do you want? Okay, but here, oh yeah, it's something like logical. If you're going to continue that one, it will not really get 0 because you keep on multiplying 1/2, 1/2, 1/2, 1/2, and so on. Therefore, there is a sort of a way of getting the sum of all these from 2 until um, infinity. Okay, until infinity, and and that is sum to infinity is equals to a sub 1 1 minus r. Specifically, this one is applicable if your common ratio is less than -1, greater than -1, but less than +1. Okay, so if obviously 0 is a restriction, maybe uh, as you can see, if the r is less than 1/2, the it's like the 1/2 here, r is 1/2, the number will become smaller, 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 or if it's negative, yes, still the same. So therefore we can use this kind of formula to get the sum of all the terms until infinity. Okay, until infinity for this type of sequence. So for that, um, the derivation is, yeah, we'll provide another video for this. Okay, so we have here s sub infinity equals a sub 1. So as you can see, the difference between the formula for the infinite sequence and the finite sequence above. So we only have a sub 1. We need a sub 1, which is 2, and 1 minus 2 equals um, no, 1 minus 1/2, because 1/2 is our sequence. So we have 2. 1 minus 1/2 is 1/2. How many 1/2 in 2? We have 4. Therefore, if we're going to add all of this, okay, add all of this sequence from 2 until infinity, we get a sum of 4. Only 4. Imagine that. So here's the interesting thing about here. Look at this. If you're going to add 2 and 1, you already get 3. And that's 4. Meaning, from 1/2 until to positive infinity, that's only 1. If you're going to add all of those. Okay? And the interesting is, yeah, this is 1/2 and 1/4. It's already 3/4. Okay, it's already 3/4. So you have already um, 3 and 3/4. If that's the case, it means that this from 1/8 until infinity, that's only 1/4 the sum. So there's only 1/4. So imagine that one. Okay, so that's for geometric series when we're getting the sum of the finite terms, which is in number 1, and if we are getting the sum of the infinite terms, which is in number 2.